Welcome to Lesson 7 of the Introduction to Python course. In this lesson, we will be discussing flow control with a focus on if conditions in Python, loops, generator functions, and list comprehensions. Now we know that our programs run sequentially. This means that they run line by line until the program has finished executing. But as we have seen earlier, it is possible to alter this flow with the help of functions. Another way to change the way a program flows is with the help of conditional statements and loops. This is what we are going to learn in this lesson. So let's start with conditional statements. Conditional statements are used to check the validity of certain conditions and then either proceed to the next part of the code or provide some output. If the conditions are met, the program continues into the statement block. If not, the program exits the statement block. Let's have a look at the syntax of an if statement. So we have if, then we have some conditions. This can be anything. Then we have some tasks. So we'll call this do this 1. We have another task, do this 2. And then we exit the if block and we give some other task, which would be something like do this 3. Now there are a couple of things to note here. First, after declaring our if statement with the necessary conditions, there's an indentation before every new line of code. This indicates that these lines are a part of the if statement code block, and the program will run these lines of code. The do this 3 function line is not indented. This is because it lies outside of the statement block, and so it will run anyway, whether the if statement conditions are met or not. Along with the if conditions, we also have the else if or elif conditions and the else conditions. Now, when the if condition is found to be false, the program will proceed to the elif conditions. These conditions are evaluated in order of their placement within the if statement block, and they will run sequentially until one of them is found to be true. In such a situation, that particular elif block will be executed and the rest of them will be skipped. Now, if the if conditions and all the given elif conditions are proved to be false, or if there are no elif conditions given after the if conditions, the program will proceed to the else block. An if statement can have 0 or more elif conditions and either 0 or 1 else condition. Let's just have a look at the syntax of an if-else and an if-elif-else statement. So we will start with the if-else statement. So we'll say if some conditions, we will say do this 1, then we have do this 2, then we will say else, and notice it's outside the if block because there's no indentation there. Then we will say do this 3. And finally, we will have do this after. This is once again outside the if and the else blocks. Now, let's see what would happen if we wanted to use an if, elif, else statement. So we have if some conditions, then we have do this 1, we have do this 2, and then we can say elif, other conditions, do this 3. And then we have else. Do this 4 and do this 5. And then we have do this after. So these are like the basic syntax of when we want to use an if-else statement and when we want to use the if-elif-else statement. Now, there's some values that are considered to be false. These include none, 0 or 0.0, and empty containers like strings, lists, tuples, etc. So we can demonstrate this using the bool function. So let's say we have bool or boolean and we say none. Now when we execute this, we get false. And let's say we have bool 0, we get false. If we say bool 0.0, false. Bool just, empty. We leave the space between the quotation marks empty, we get false. And bool empty list, false. So the bool function is used to convert a value into a Boolean value. As you can see, all of these commands return false as their respective outputs. Now let's have a look at Python's comparison operators. So we have equals, doesn't equal, is greater than, is less than, is greater than or equal to, is less than or equal to, is the same object, and is not the same object. Along with these, Python includes the following membership operators. So we have in, which is true if the value is found in the given sequence. So for example, let's say we have a in A, B, C. And then we have A in ABC. Let's just make the correction here. This should be a string, not a variable. So there we go. We get the output as true. Next, we have not in. So this is true if the value is not found in the sequence. So for example, let's say we said A not in, and then the same list as before, A, B, and C. So when we print this, this gives us false. Now, let's say we had D not in ABC. If we execute this, it gives us true. Let's see how we can use the if-elif-else statement in a piece of code. So this is how we use comparison operators and membership operators. Now let's see an example of how we can use the if, elif, and else statement in a piece of code. So let's say we have define our main function, then we have age equal to integer, input how old are you, then we have if age greater than equal to 21, we print you can vote and drink. Elif age greater than equal to 18, we print you can vote but cannot drink. Finally, we have else, and we print you cannot vote or or drink. And then we call our main function. So let's test this out. Let's say we put something like 32. So it says that we can vote and drink. Now let's try, so we have 21. So let's try 20. It says we can vote but cannot drink. Next, let's try 12. It says we cannot vote or drink. So as you can see, this is how we can use the if, elif, else statement within a program. Pretty cool, right? Now let's get into the slightly more complex parts of conditional statements by learning about compound conditions. At times, we may have if statements that are a little more complicated than what we have seen so far. These would require multiple conditions to be checked. Let's have a look at some logical operators that are used to check several conditions and to negate Boolean values. First, we have the AND operator. So, for example, we can have if A and B followed by whatever necessary conditions. Along similar lines, we have the OR operator. For example, we can have if A or B followed by the required conditions. Finally, we have the NOT operator. Now this is used to negate a Boolean value. This means that it can turn true to false and false to true. So for example, we can have if not A and then the given conditions. So the same thing is just basically mentioned over here. So we have the operator, the name of the operator, and an example. So we have AND, we have OR, and we have NOT. So let's see an example of how to use these operators within a program. So let's define our main function. Don't forget the colons. We have age equal to integer, input, how old are you? Then we have is citizen, and we say input, are you a citizen, Y or N, which is yes or no, basically. Then we say dot lower equal to Y. Then we say if age greater than equal to 21 and is citizen, we say print, you can vote and drink. Elif, age greater than equal to 21, we print, you can drink but cannot vote. Elif, age greater than equal to 18 and is citizen, print, you can vote but cannot drink. Else, print, you cannot vote or drink. All right, now let's call our main function and see what happens. Okay, so this throws an error because I have made an error here. That's right, so there we go. Okay, there's a typo there, but we can ignore it for now. So it says, how old are you? So let's say we say that we are 32. It asks us, are you a citizen? I say yes, I can vote and drink. Now, let's say I say 32, but no to am I a citizen? It says I can drink but cannot vote. Now, let's say I am 20 and I'm not a citizen. I cannot vote or drink. If I'm 20 and I am a citizen, I can vote, but I cannot drink. Now, let's say I am not a citizen. I cannot vote or drink. So you can see that the is citizen is assigned to a comparison expression. So the user enters capital Y or small y, is citizen will be true. Otherwise, it will be false. Now we will have a look at the is and the is not operators. The is and is not operators vary from the equal to and does not equal to operators. The is and is not operators check if two objects are one and the same object. The equal to and does not equal to operators check if two objects have the same value. So we can understand this better with the help of some code. So first we will create two lists, A and B. So we have A, 1, 2, 3, 4. We have B, 1, 2, 3, 4. And then we will create list C and we will just equate it to A. All right, so now let's check if A and B have the same values. So we say A equal to B. This says true because A and B have the same values. Now, if we check whether A and B are the same object, by saying A is B, we get false. Next, let's check whether A and C are the same object. And if we check whether they have the same value, this is true too. Now let's just quickly check the IDs of A, B, and C. So we have ID of A, ID of B, and ID of C. When we execute this, we get the ID of A as some unique value, the ID of B as another unique value, and the ID of C, surprisingly, is the same as the ID of A. And let's say we append a new element like 5 to A. And now when we print A, and we also print C, we can see that even though all we have done is just said append with A, this element 5 also gets appended to C. So what exactly happened here? So basically, while A and B are different objects, A and C are the same object. While A and B have similar values, they are assigned separately, and this makes them completely distinct objects. On the other hand, C is assigned to A, which means that C and A are both the same object. As you can see in this diagram here, A and B point to two different memory locations, while A and C point to the same memory location. Now let's have a quick look at the all and any functions. All and any are two built-in Python functions that are used to loop through an iterable to evaluate the Boolean value of the elements of that iterable. Now, if all the elements of the iterable evaluate to true, the all function returns true. And if any of the elements of the iterable evaluate to true, the any function returns true. And that's about it. As simple as that. Next, we have the ternary operator. So Python, as well as most other programming languages, have something called a ternary conditional operator. This is usually used for conditional variable assignment. The syntax looks something like this. So we have on true if expression else on false. Now let's see this used in some code. Let's consider a very simple code. So let's say we have if season equal to summer and color equal to white, else and color equal to black. Now this code required 4 lines just to assign a value to the variable pant color. We can simplify this code with the help of the ternary operator, something like this. So we would say pant color equal to white if season equal to summer else black. Now, the expression mentioned here is not limited to any particular type. It can be any type of expression, including a function call that returns either true or false. So for example, if we had a function called isSummer, we could do something like this. So let's say we have pant color equal to white if isSummer, which is the function that we just assume that we have, else black. So as mentioned before, it can be any kind of expression, including a function call. Next, we have the in-between function. In-between is used to check if a value lies in between two values. The syntax looks something like this. So we have if low value is less than your value is less than high value, then we can continue with the rest of the code. So let's take an example here. Let's say we have age equal to 15. Then we say if 12 less than age less than 20, we print you are a teenager. Then we have if 13 less than equal to age less than equal to 19. We print you are a teenager. So we can use the same syntax when working with other types of objects as well, like strings and dates. Now let's talk about loops. Loops are one of the most powerful ways to carry out various necessary operations within our code. They allow us to loop or iterate over code blocks. There are 2 types of loops in Python, while loops and for loops. Let's have a look at while loops first. While loops evaluate the given conditions. If these conditions are found to be true, the code block is executed repeatedly until the condition is no longer true. Let's consider this example. So we have num equal to 0. Then we say while num less than 6. Hold on, let's just correct that. Okay. We print num. Then we say num plus equal to 1. Then when we execute this, the program keeps running until it reaches 6. And once it reaches 6, it exits the loop. Now, while loops can be used to continue prompting a user for some input until it receives a value that is acceptable to the program. So we can see this in the next example. Let's say we define some function called isValidAge, and we throw in the parameter s. Now we say return s.isDigit and 1 less than equal to integer s, which is less than equal to 113. Then we define the main function. We have age equal to input how old are you, while not is valid age age is equal to input, please enter a real age as a number. So basically it checks the condition to make sure that first of all it's a number, and second of all it lies between 1 and 113, including 1 and 113. Now we say age equal to integer age, and then we do pretty much what we did before. So we say if age is greater than equal to 21, print you can vote or drink. Then we say elif age greater than equal to 18, print you can vote but cannot drink. Else we print you cannot vote or drink. Now let's call our main function and see how this program would work. So it says, how old are you? Now, let's just, play around with this a little bit. So let's say I just type in, let's say I type in an age, but I type it in words. So I say something like 30. Now it says, please enter real age as a number. Let's say I just randomly typed in a word like kitten. It says, please enter real age as a number. Now let's say I type in 1,342. Once again, it prompts me to enter a real age as a number. So now let's be generous and let's type in a real age. So let's say I go with 40. It says that I can vote or drink. So we will now see how to combine if conditional statements and while loops to create a simple guessing game in which the computer randomly generates a number between 1 and 100 and the user has to guess what that number is. We will start by importing random. All right, now we define our function. So we say def and we say is valid num with the parameter s, and we return s dot is digit and 1 less than equal to integer s less than equal to 100. So basically over here, we are making sure that the number is a digit and that it lies between 1 and 100. Next, we define our main function. So first we need to get a random number between 1 and 100. So let's define number equal to random dot rand int 1 comma 100. And then we set this the guessed number to false to start with. It'll be set to true when the user guesses a number. So we say guessed number equal to false. Next, we have to get the user's guess. So we say guess equal to input, guess a number between 1 and 100. We set the number of guesses to be 0, and we'll increment by 1 after each guess. Now we need to keep looping until the user guesses the number. So we open a while loop. Let me actually just, okay. So we say while not guessed number. So first we make sure that the number is valid. So we say if not is valid num guess. We say print and we give a message like I won't count that one. Then we say guess equal to input a number between 1 and 100, please. Then we say else, which means that, the number is valid, and we say num guesses plus equal to 1, which is incrementing this value, and then we say guess equal to integer guess. So basically we convert the user's guess to an integer. So now we need to write code to check whether the guess is correct or wrong. So if the guess is wrong, we need to provide information and we need to ask for another guess from the user. So we say if guess is less than number, guess is equal to input, too low, please try again. Yeah. Then we say elif guess greater than number. We say guess equal to Input too high. Please try again. Else, print, you got it in, comma, num guesses, comma, guesses. And then we say guessed number equal to true, which will break the program out of the loop. And then we say print thanks for playing. So that's about it for our program. And now when we call our main function, so we are prompted to provide some random value here. So first, let's say something like hello. So this won't be counted because it checks the validity of what we have put. If this is not a number, it doesn't accept the value. Now, let's say we try something like 10,000. Okay, so let me do this. Now let's try this and see what happens. So if I say 10,000, there we go. So that fixed the error. All right. Now let's try to actually play the game. So let's start with 50. It says too high, please try again. So let me go with 20. It says too low, please try again. So let's try 30. Too low. 35. Too low. 38. I got it in 4 guesses. So it prints out this message, you got it in this many guesses. It counts how many guesses I made, and then it says, thanks for playing. So in this way, we can use a combination of functions and methods in Python to come up with various kinds of programs, just like this guessing game. All right, so now let's take a look at for loops. For loops are used to loop through an iterator, like a range, list, tuple, or dictionary. The syntax looks something like this. So we have for item in sequence name, and then do something, item. So now let's loop through a range. So let's say we want to loop through a range of values. We can do it like this. So we say for num in range 6. We print num. Then we print a new line. And then we say for num in range 0, 6, print num. As you can see, we get these values here. So we print out all the numbers starting from 0 until 6, not including 6. As we can see here, a range goes up to, but does not include the stop value. And here the stop value is 6. Now let's see how to skip steps. So let's say we have for num in range. So the start value is 1, stop value is 11, and then we give a step size of 2. 2. 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 Now we say print num. So this gives us all the values starting from 1 until 11, but it skips every two numbers and then prints out the third number. So for example, we have 1, and then it skips 2, and then it shifts to 3. So as you can see, this code prints out all the values starting from the start value, which is 1, until the stop value, which is 11, and it has a step size of 2. So it prints 1, it skips 2, it goes to 3, skips 4, goes to 5, and so on until it reaches 9. And when it skips 10, it goes straight to 11, which it will not print because that is a stop value. So that's why it just ends at 9. Now we can also skip steps backwards. Let's see this in this example. So we have for num in range 10, 0, minus 1. And then we print num. So when we execute this, we get all the numbers starting from 10 until 0 and having a step size of minus 1. So basically it goes 10, 9, 8, 7, so on until 1. So now let's see how we can loop through a list and a tuple. Let's see we have some list nums equal to 0, 1, 2, 3, 4, and 5. Then we have for num in nums. We print num. And then we print new line. Then we have nums equal to 0, 1, 2, 3, 4, 5. Then we say for num in nums. And then we print num. So as you can see, we first created a list and we looped through that list to print all of its values. Then we created a tuple with the same values and we created a for loop that would loop through these values and print it out. Now let's see how to loop through a dictionary. So let's say we have a dictionary of grades and we have English with a 97. We have math with a 93. We have art with a 74. And we have music with an 86. All right, so now what we can do is we say for course in grades print course. So here it prints only the course names, which is English, math, art, and music. Now let's loop through the keys of the dictionary. So we say for course in grades dot keys print course. So this gives us the keys of the dictionary, which is basically the course names. Next, we will loop through the values of a dictionary. So we say for grade in grades dot values then we print grade. So that gives us only the values in the dictionary, which is 97, 93, 74, and 86. Now let's say we want to loop through all the items of the dictionary. So we will say for course, comma, grade in grades dot items we print f course and then grade. Okay, I see my mistake here. So as you can see, a lot of the times these minor little mistakes can make a difference to the program. Right. So now we get all the items in the dictionary, which is English 97, Math 93, Art 74, and Music 86. Now just pay attention to the way the variables are unpacked. So it goes like this. For course, comma, grade in grades dot items. So this is how we can call these variables from the dictionary. Now the items method returns a dictionary items object, which is basically a pseudo list of tuples. Something like this. So we have dict items and then we have English comma 97. We have math comma 93. We have art comma 74. We have music comma 86. So in each of these tuples, the first item is the name of the course and the second item is the value of the grade. Now we can also write this loop like this. So we can say for item in grades dot items course is equal to item 0, grade is equal to item 1, and then print f course grade Now when we execute this, we get all the items from the dictionary. So while this method is not exactly incorrect, the previous method is more acceptable to Python developers. Now let's jump into an exercise where we will play around with the all true and any true functions in Python. First, let's take a look at the problem statement. It says that we need to use loops to write all true and any true functions that behave in the same way as the actual built-in all and any functions. All true should return true as the output if and only if all the elements passed into the iterable are true. Any true should return true if at least one of the elements passed into the iterable is true. We also need to keep in mind that we need the output to be generated as quickly as possible. This means that if we pass a list of about, let's say, 1 million values to the all true function, and the very first value in the list is false, the function should exit the loop. So here's what the sample output would probably look like. Now, let's just write the basic code first. So we would have something like this. We would define our function. We would define it as all true. We would pass in iterable. And over here, we would have to write our function, whatever it is. We'll just leave this like this for now. Now, second, we would have to define the anyTrue function. Once again, pass in iterable. Write our function. And then pass. Finally, we define our main function. We say A is equal to all true 1 0 1 1 1. B is equal to all true 1 1 1 1 1. C is equal to any true 0 0 0 1 1. D is equal to any true 0 0 0 0 0. Then we print A, B, C, and D. And that's about it. Then we would have to call our main function. All right, so this is just the basic body of the code. Now we will get to the actual content of our code. So let's just copy this, paste it here. So let's flesh this out. So first we will work on the all true function. So we say for item in iterable, if not item, return false. Then return true. So basically this returns false if any item is false, and if we made it through the loop without returning false, then all the items are true. Next we come to the anyTrue function. So we say for item in iterable, if item return true, return false. So we return true if any item is true, and if we made it through the loop without returning true, then all items are false. And then after that we have this, the main function. We print A, B, C, and D, and then we can call our main function. So let's see what happens when we run this code. Exactly, so we get false, true, true, and false. As you can see over here, the first value is false because they are all not true. The second one is true because they all are true. The third one is also true because we do have at least one of the values that's true. And the fourth one is false because none of the values are true. So there we go. This is how we can use loops to create functions that can replicate Python's built-in functions. Now let's move on to break and continue. So as the name suggests, we use the break statement to break out of a loop. Let's have a look at an example here. let's say we have for num in range 11 to 20, we print num. And if num modulus 5 is equal to 0, break out of the loop. So as you can see, we look for the range of numbers from 11 to 20, which is what is printed here. Now, what we've done is we have tried to find the quotient when dividing the particular number by 5. So if the remainder rather is 0, then we break out of the loop. And that is what happened here. Basically, because 15 divided by 5 is equal to 0, or rather has a remainder of 0, the loop will stop after printing 15. So now we insert the continue statement to jump to the next iteration of a loop without executing the remaining statements in the block. So let's take a look at an example here. So we say for num in range 1, 12, if num modulus 5 is equal to 0, we continue. And then we print num. So as you can see here, we first look for all the values within the range 1 to 12. And then whatever number divided by 5 gives a remainder of 0 is skipped, and the loop continues with the rest of the numbers. So for example, you can see here that we have 1, 2, 3, and 4, but 5 is missing because 5 divided by 5 will give a remainder of 0. Likewise, we go 6, 7, 8, 9, and 10 is missing because 10 divided by 5 will give a remainder of 0. And this would go on depending on, the range that we give. Now, let's try writing our guessing game again. If you remember, we wrote the guess the number game just a little while ago. So let's try writing the same game again, but this time we will use the continue statement instead of an else block. So we import random. We define is valid number. Most of the steps will be the same, so there's no need to go into detail into all of those steps. We return s dot is digit, and 1 less than equal to integer s less than equal to 100. Then we define the main function. Then we have number equal to random dot rand int 1 1 100 1 100 guessed number equal to false, guess equal to input, guess a number between 1 and 100. Num guesses equal to 0. Then we open a while loop, while not guessed number if not is valid num guess print I won't count that one. guess, input a number between 1 and 100, please. And then we continue. So this would skip to the next iteration through the loop. We have num guesses plus equal to 1. We have guess equal to integer guess. Then we have if guess is less than number. Guess is equal to input. Below. Guess again. Then we have elif guess greater than number. Guess equal to input too high. Guess again. Then we have else. And we print you got it in, comma, number of guesses, comma, guesses. Then we have guessed number equal to true. Then we have print. Thanks for playing. All right, so now let's execute this program and see how it works. So it says the word contains 5 letters. Guess a letter or a 5-letter word. Let's say we just randomly guess some letters. Let's go with E. Okay, the word has no E's, then we go with A. The word has one A. We'll go with P. The word has no P's. Now, just to make this process a little faster, since this is just a demo, let's go back and see the options that we had. All right, so our possible answers could be either Patty or Sally. Now, since we know that this doesn't have a P, let's try S. All right, it has S and A, so we know that the answer is Sally. So it tells us Sally it is, and it tells us how many tries we took, and in this case it was 5 tries. So this is basically how we can create a nice little game with the help of the different kinds of loops that we have. Now, if you remember, there was also, yes, an extra challenge over here. It says create your own list of words in a separate file, and then use the words from that file in the get word function. Now, this is something that you can try on your own. So all you need to do is just create a file, add some words to it, and then access these words with the help of the get word function, as you can see over here. So go ahead and try it. See how well you can get the code running. All right, now let's move on to the else clause of loops. So after for and while loops have finished iterating, the program can be written to move ahead to an optional else clause. We'll see how this works in the following example. So let's say we have our main function. So we define main, then we say print, example 1, for loop, num equal to integer input, enter a number. I in range 5 if I is equal to num break. So we break out of the loop. And then we print I. Else we print F completed iterating without reaching num. Right, this let me just, yeah, there we go. Now we say print new line example 2 while loop. I is equal to 0, num is equal to int, input, enter a number. While I is less than equal to 5, if I is equal to num, break, print I plus equal to 1, else print F completed iterating without reaching num. That's it. Now we can call our main function. So when we run this code, it tells us to enter a number. So let's enter a random number. Let's just go with 3. So you can see that it enters, it displays 0, 1, and 2. Now let's say for while loop, we enter the number 7. So it goes until 5, and then it says completed iterating without reaching 7. So as we can see, the program completes all the loop's iterations and then leads to the else clause being executed as well. So let's see what happened here. Now in the first case, we entered a number that is less than 5. Now in the program, we said if the number is less than 5, the program needs to break out of the loop without completing, which is what happened. Now in the second case, we entered a number that is greater than 5. And in the program, we said that if the number is greater than 5, the program should complete the loops, all the loops iterations, and then the else clause will be executed. And that's what happened here. Now, another example of using an else clause is for checking some kind of inputted text for blacklisted words. So let's say we have a list. We will call it black list. Now, let's fill this list with random stuff. So let's just say something like sugar, just remove the caps lock. Sugar, fudge, chips. Now, I know these aren't actual blacklisted words, but since this is just a demo, let's just assume that these would be blacklisted words. And sprinkles. Now let's define our main function. Now we will go to sentence equal to input sentence. So this will take some sentence from the user. Then we say forward in sentence dot split if word in blacklist print. Please don't say that. Then we break out of the loop. Else print that's an appreciated sentence. Now we can call our main function. So input a sentence. Let's say we say something like the tea has enough sugar. Right, you can see there's an error here. Now that is because of this. There we go. This is the correct indentation. Now if we rerun this and we say the tea has enough sugar, it says please don't say that because we've used the word sugar, which is in the blacklist. Now, here's something interesting. So we will rerun this cell and now we will say the same thing. The tea has enough sugar, but this time we will add a period at the end. And let's see what happens. It says that's an appreciated sentence, even though there is a word from the blacklist. So why do you think that happened? Now this happened because right after sugar is a period. So Python interprets this as one entire string, and it doesn't realize that this particular word is contained in the blacklist and that the period is just a punctuation mark. So it's very minute things like this that can make a huge difference to the outcome of our program. That is why when we are programming, we need to be very careful and we need to really think things through. Because there might be various kinds of details that can hugely affect the output of our program. Now let's move on to the enumerate function. So usually in programming languages, we write code that would look something like this. So we have I equal to 1 for item in A, B, C. We print I, item, and separator. I plus equal to 1. So this would give us an output like this. Now we can do the same thing but in a more Pythonic style of writing code. So this would involve the enumerate function. Now when using this function, the code would look something like this. So we have for I, comma item, in enumerate A, B, C. And over here, right after the square bracket, we say comma 1. Then we print I, comma item, comma separator equal to period space. And when we run this, as you can see, we get the same output as what we got before. So in this way, we can get the output that we require without having to create a new variable to hold a count. Now the enumerate function accepts two arguments. First, the iterable to enumerate, and second, the number at which to start counting, which by default is 0. So here the iterable is this list over here, and the number at which you start counting here in this case is 1. But if we had not specified this, by default it would be 0. So this would return an iterable of 2 element tuples which have the format count, comma, value. Now let's move on to generators in Python. So what exactly is a generator in Python? Generators are iterators that are written with special generator functions, and they can only be iterated through one at a time. So how are they different from standard iterators? Let's see this with the help of an example. Let's first consider a standard iterator, something like this. So we will import random, then we will define get random numbers with low, high, and num. Then we have numbers equal to empty list for number in range num. Numbers dot append random dot randint low comma high, and then we return numbers. Then we have numbers equal to get random numbers 1 comma 100 comma 5. Then we print first time through for num in numbers we print num. Then we print second time through for num in numbers print num. All right, now let's execute this. So as you can see, we get first time through and a bunch of random numbers, followed by second time through and a bunch of random numbers. Now the code consists of a getRandomNumbers function, which returns a list of random numbers of count num. And these numbers lie between the low and the high values. So we assign this list to the numbers variable and then loop through it twice. Now we can loop through this list any number of times. Now, let's consider the following code that we are going to be typing, which would accomplish the same task, but uses a generator instead. So we say import random, then we define get random numbers, low, high, num, and then for number in range num, yield random dot randint low comma high. Then we say numbers equal to get random numbers 105. And then the same thing as before, first time through. For num in numbers, print num, and then print second time through. For num in numbers, print num. All right, now before we run this, I realize there's a small mistake here. Right, this should be numbers. Now let's run this and see what happens. Right, so we get this as the output. So basically, both the functions follow pretty much the same method, but we can see that the second function, which uses a generator, is much cleaner compared to the first function. This is because there's no need for the numbers local variable. As you can see here, the generator function works through the for loop and produces each result one by one. But we can only iterate through the generator once, which is why the output came like this. If you want to iterate through the generator more than once, we would need to call the generator function again. We'll see this in the next example. So over here, we will import random, then we will define get rand nums low high num. Then we have for number in range num yield random dot randint low comma high. Then we print, let's just leave a, okay. So then we print first time through, then we say for num in get rand nums 105. Print num. Then we have print second time through. For num in get rand nums 105. We print num. Now when we execute this, we can see that we get first time through and we get second time through. And each time we get two different outputs. So basically we get different outputs each time you call the generator function because it returns a random sequence of numbers. Now if we want to get the same output every time, we would need to create a function that returns a list of predefined numbers. Otherwise, we would just get some random numbers. All right, so when do we use generators? We use generators when we need to proceed to the next item in a sequence without creating the entire sequence in advance. For example, let's say we have define odd numbers then we say I equal to -1. Then we have while true. I plus equal to 2, and we yield I. Now we define our main function, and we say for I in odd numbers, print I. If input enter for next or Q to quit, Q, we print goodbye, and we break. And now we can call our main function and see what happens. So when you execute this, it says press enter for next or Q to quit. So if you press enter, we get some number. Now if you press enter again, we get another number. Now suppose we press Q, it says goodbye, which basically means that it quit the program. So as we can see, the program took an input from the user with every iteration. When the user allowed the code to move ahead, it did. When the user gave the keyword to stop, the program stopped executing the loop. This is essentially how generators are used in programming. Now next we have the Fibonacci sequence. The name might sound a bit familiar, right? The Fibonacci sequence is a sequence that is popularly used in mathematics. In this sequence, each number is the sum of the two previous numbers. That's it. So let's see how we can write a Python program to print out the Fibonacci sequence one number at a time. So let's define our function, which in this case will be Fibonacci. Then we have a, b equal to 0, 1. Then we say while true, yield a. Then we have a comma b equal to b comma a plus b. So basically we have a comma b equal to b and then a plus b. Then we have our next function, which will be our main function. For I in Fibonacci, we print I, and then if input enter, actually press enter for next or Q to quit. Equal to Q, print goodbye, and break. So now we can call our main function and then execute this. So it starts with 0. Now when we press enter, it gives us 1. Press enter again, gives us 1 again. Press enter again, gives us 2. And then we get 3, 5, 8, and so on. This is basically the Fibonacci sequence. Now when we press Q, it says goodbye. So this is basically how we can use generators to generate the Fibonacci sequence. Now let's say we need to work with a sequence of unknown length. So for example, in bingo, the caller needs to keep calling out numbers until someone finally wins the game. Nobody knows how many numbers need to be called out until there is a winner. So let's see how that would work as a Python program. So we will say import random, then we define bingo, our function bingo. Then we have balls equal to b, list range 1 comma 16. Then we have I list from range 16 comma 31. Then we have n list range 31 to 46. Then we have G list range 46, 61. Finally, we have O, which is a list from range 61 to 76. Right. Next, we will open a while loop. So we'll say while balls, and then we say letter equal to random dot choice list balls dot keys. Then we have number equal to random dot choice balls letter. Then we have balls letter dot remove number. So this would remove a number from the letter list. Then we say if not balls letter. So basically if the letter has no more numbers, we print removing followed by the letter. Then we say delete balls letter. So this would delete the letter from the dictionary. And then we yield letter, comma, number. Now we can define our main function. We say for ball in bingo, and then we print ball. If input enter or next ball or Q to quit. And if this is equal to Q, we print Thanks for playing. Goodbye. And we break. Else, hold on, this should go there. Else, we print all out of balls. Now we can call our main function. So let's execute this and see what happens. So it gives us the first ball, and then it says enter for the next ball or Q to quit. So if we keep pressing enter, and then it gives us another ball. We press enter again, it gives us another ball. So we can go on a couple of times and keep this going. And if we want to exit this, we just press Q, and it says thanks for playing, goodbye. So in this program, the generator function will keep generating bingo balls until it runs out of balls. Now we'll move on to the next function. So in order to be an iterator, an object needs to have a next method, which would return the next item of the iterator. Python has a built-in iter or next function that calls the next method of the iter. We will see how to use this function with a generator to play a game of rock, paper, scissors, also called Rochambeau, against the computer. So let's begin our program. We will import random. Now we will define our Rochambeau function, and we will give it the parameter weapons. Then we will say while true, yield random.choice weapons. Now we define play weapons choice Python weapons. Then we have your weapon equal to weapons integer choice -1. Then we have Python weapon equal to next Python weapons. Now we will begin with an if loop, if else. Now we will add an if conditional statement. So we will say if your weapon is equal to Python weapon, we will print tie. You both chose and then we will print out the weapon that we have both chosen. Now we will say else if your weapon is equal to scissors and Python weapon is equal to paper. Now we can actually copy and paste the same line. Once again, we will say, okay, there's a bit of a error here. There we go. This should fix it now. Or Now, let's just quickly change values here. So in this case, we will have your weapon as paper, and Python weapon will be rock. And now in the third case, we will have your weapon as rock and Python weapon as scissors. So we will print you win your weapon beats Python weapon. We will print you lose Python weapon beats your weapon. Then we print a bunch of hyphens just as part of the, you could consider part of the decoration actually. Now we will define our next function, which will be make choice. So this says choice input choose your weapon. We have rock, paper, scissors. And we also have Q, which would let us quit the program. Then we say return choice. All right, so now that we have this, the last thing that we need to do is define our main function. Weapons equal to rock, paper, scissors. Then we have Python weapons equal to Rochambeau weapons, and choice equal to make choice. And then we say while choice in 1, 2, 3. We play weapons, choice, and Python weapons. Basically, we call the play function. And choice will be equal to make choice. Then we print goodbye. And now we can call our main function and execute this program. So it says choose your weapon. So let's say I choose rock. it says you lose, paper beats rock. Now let me choose a weapon again. So let's say this time I choose paper. It says you win, paper beats rock. And if I choose scissors, you win, scissors beats paper. So these are all the weapons that I have chosen. Here I chose rock, here I chose paper, and here I chose scissors. And Python, on the other hand, randomly generates a choice. So in this case, it chose paper, and that's why I lost. In this case, it chose rock, and that's why I won. And in this case, it chose paper, which is why I won again. Now, if I want to quit, I can just type in Q, and it says goodbye. Now, in this program, we assigned a generator instead of a list to weapons. The advantage of this step is that we don't need to know the total number of iterations. The generator will just generate a new result every time the next method is called by the program. Now, one thing to note here is that the Rochambeau generator is given in a very simplistic way in this program, but we can give it a couple of weapon preferences. Something like this. So let's say in our Rochambeau function, we say while true, num is equal to random dot random, and if num is less than 0.5, yield weapons zero. Elif num less than 0.8, yield weapons 1. Else yield weapons 2. So something like this. So we can continue using generators and then continue to make it either more complex or more simple depending on what we're trying to achieve and how quickly and how efficiently we are trying to achieve it. All right, so now let's move on to list comprehensions. List comprehensions can be used to create new lists from already existing sequences. This is done by taking a subset of the sequence and or altering the members of the sequence. So to understand this, we first will create a new list from a list using a for loop. So let's say we have squares. Then we will say for I in range 10. Then we say squares dot append I asterisks I. Then we print squares. On executing, we get this. Now we can do the same thing, but in a more simplistic way using this comprehension. The syntax would look something like this. So we would have new list equal to modify item for item in items. Here, modify item represents any change that is made to the item. Using the syntax, we can write our code. It would look something like this. So we have squares equal to I times I for I in range 10. So this is basically how we can rewrite the code. Now let's take a look at another example. In this case, we will first take a list of people's names, and then we will use list comprehension to generate a list of their initials. This creates a new list by passing each of its elements to the initials function. So let's define our function initials with a parameter name. Then we will say full name, name dot split, based on the space. Then we will say inits equal to full name 0 0 and full name 1 0. Then we will return inits. Now we define our main function. And now we create the list of different names. So we can have random names here. Let's just go with some very simple ones. So let's go with Jane Doe, George, Joseph, Dominic, Savio, and Laura Lacuna. Now we have inits equal to initials, name, for name in names. Then we will say for I in inits, print f I 0 I 1. Then we can call our main function. So when we run this code, I think you'll be able to understand better what happened. So as you can see, this program took the names that are mentioned in this list, split them based on the separator, which in this case is a space, and then it took the first letter of the first name and the first letter of the last name and turned that into a separate list. So it did this for each name and then added it to a new list, and then finally printed out the list of initials. Now let's take a look at another example. So do you remember our addNums function from the iterables lesson? We can improve it using list comprehension. So let's define our addNums function with num asterisk nums. Then we have total equal to sum nums, num. Then we have print f, the sum of nums and num is total. Now we define our main function. So we say add nums 1, 2, add nums 1, 2, 3, 4, 5, add nums 11, 12, 13, 14, and add nums 101, 201, and 301. Now we can call our main function. So we can see that we get the output that we want. So if you remember, this is the output that we got when we wrote this program. Now let's see how we can improve it using list comprehension. So we define add nums, num asterisk nums total equal to sum nums num. Num joined equal to join string n for n in nums. Then we print f, the sum of nums joined and num is total. Then we define main. We say add nums 1, 2. Pretty much the same as before, so we can actually just copy paste all of this. Now we can call our main function. And when we run this, we get the same output. And so, with the help of list comprehension, we can convert the list of numbers into a list of strings, and we can then join the list on the comma in a single step. Now let's see how to create sublists with list comprehensions. This is done using the optional if clause. So the syntax, if you remember, looks something like this. We have new list equal to item for item in items if some condition. Now let's say that we want to get all the 3-letter words from a list of words. So let's first just write this without list comprehension. So in a very simple way, it would be 3-letter words Then we have for word in words. If length of word is equal to 3, three-letter words dot append word. So this would be basically how we would do it without list comprehension. Now we can do the same thing, but we can use list comprehension. So let's define our main function. Now let's create our list of words. So let's just have some random ones here. Let's start with cat, hat, orange, banana, bat. Now we will say three-letter words is equal to W for W in words if length of W is equal to 3. Then we print 3-letter words. And then we can call our main function. So when we execute this, as you can see from this list of 1, 2, 3, 4, 5 words, it prints out only the 3-letter words, which are cat, hat, and fat. So here we have combined an if condition within a for loop into one single line. And there we go. So in this lesson, we've learned how to write if, elif, and else conditions, and how to loop through sequences. We've also learned about the enumerate function, generators, and list comprehensions.